Welcome back, everybody. Today we're going deep on some really interesting AI work with this new open source large language model called DeepSeek. You know, you sent over this research paper, deepseek.pdf.
Right.
And I have to say, it's got me pretty excited to dig into this.
Yeah, no, it is a fascinating project. And, you know, I think what makes it so interesting is this kind of ambition behind it.
Yeah.
You know, DeepSeek is part of this larger movement towards building open source AGI.
Okay, wait, hold on. I know we throw around AI, you know, all the time these days, but AGI, artificial general intelligence.
Yeah.
That sounds like something straight out of, you know, science fiction.
It kind of is. But what's exciting is that we're getting closer to making it a reality. And the open source part is key here.
Right.
It means anyone can access the code, the data, everything.
Yeah.
It really democratizes this powerful technology.
So DeepSeek is like a step towards this super smart AI, and they're doing it completely in the open.
Yeah.
It's pretty wild.
Yeah.
But haven't there been other open source LLMs before?
There have been.
What makes DeepSeek so different?
They've often struggled with, you know, handling really complex tasks. It's a bit of a balancing act.
Okay.
You need a large model to handle complex stuff, but then you need even more data and computing power to train it. And that can get really expensive and resource intensive.
So that's where DeepSeek comes in with its secret sauce, right?
Exactly.
I was reading about how they use this massive data set
Yeah.
and this really clever approach to scaling.
They tackle this challenge head on. First off, they trained DeepSeek on a massive data set.
Yeah.
2 trillion tokens.
Wow.
Imagine all the words in a library.
Yeah.
And they focused on getting a good mix of Chinese and English text.
Yeah, the paper kept mentioning deduplication.
Oh, yeah.
They really went all in on making sure the data was clean
They didn't want just a huge pile of data. They wanted a high-quality, diverse data set. By meticulously removing duplicate information from web archives, they actually ended up removing 4 times more redundant data than usual.
Wow, that's some serious data cleaning. But let's get into the juicy stuff. How did they actually scale DeepSeek with all that data?
This is where it gets really interesting for data science folks like you.
Okay.
They focused on non-embedding FLOPs per token.
Okay.
Essentially, a more accurate way to measure how much computational oomph the model needs to process information.
I'm going to need you to break that down a bit for me. It sounds like they found a smarter way to measure the model's, you know, brain power.
Exactly. Think of it like measuring the efficiency of a car engine.
Okay.
You look at both the fuel it uses and the power it puts out. They figured out how to do that for their AI model, and it allowed them to predict how well DeepSeek would perform at different sizes, even before fully training it.
So they could basically predict how smart DeepSeek would become just based on how big they made it.
Yeah.
That's incredible.
And their predictions were spot on, both for the DeepSeek 7B and the larger 67B models.
Okay.
This is a really big deal because it means they can build better models more efficiently.
Okay, that's super cool. But did they also discover something about data quality impacting this whole scaling thing?
They did. This was one of the most surprising findings.
Okay.
The quality of the data actually influences how well the model scales.
Right.
Better data means you can build larger, more powerful models with the same computational resources.
Wait, so you're saying that just by improving the data, they can get better AI without needing more powerful computers?
Yeah.
That sounds almost too good to be true.
It's one of those aha moments in research where a simple insight has huge implications.
Right.
This is a really important point because it suggests that focusing on data quality could be a game changer for the future of AI development.
That opens up a whole can of worms about how we even measure data quality, right?
I'm starting to see why you were so excited about this paper. It's a really exciting area of research.
Yeah.
And DeepSeek is definitely pushing the boundaries. But, you know, all this talk about data quality and scaling makes me even more curious to see how DeepSeek actually performs.
Right. Let's get to the head-to-head competition. I know you were eager to tell me all about how DeepSeek stacks up against the big players, especially Llama 2.
Oh, absolutely.
Okay.
Let's dive into the benchmarks and see how DeepSeek performs in the real world.
Hit me with it. What did the researchers find when they put DeepSeek to the test?
Well, they ran a battery of standard tests, and DeepSeek 67B really shone, especially in code, math, and reasoning tasks. It actually outperformed LlamaDay 270B on many of these tests.
So DeepSeek is a coding whiz and a mathlete. That's pretty impressive. Can you give me some concrete examples?
Sure. For example, in GSM-8K, a benchmark designed to test grade school math problems.
Right.
DeepSeek 67B scored significantly higher than Llama A2.
Okay.
They also used human AVIL, which is a very tough test for code generation. And again, DeepSeek 67B came out on top.
So DeepSeek can basically write code and solve math problems better than some of the leading LLMs out there.
Yeah.
That's wild. Do you think it all comes back to that focus on data quality we were talking about?
I think it plays a big role. The researchers believe DeepSeek's superior performance in these areas stems directly from their careful approach to data selection and training. They specifically emphasized reasoning and problem-solving skills.
That's really exciting.